Hello everyone, let's talk about the linear optimization analysis in this lecture. When we make business decisions in practice, we frequently want to reach some extreme values. For instance, minimum cost, maximum profits, and so on. We call these extreme values optimal values. The process of reaching the optimal values is called the optimization process. Certainly, if we want to reach the optimal values, such as minimum cost or maximum profit, we have to consider several influential factors. If we can find out how these influential factors influence us to reach the optimal values, this analysis process is called the optimization analysis process. In this lecture, I will talk about the first type of optimization analysis. It's called the linear optimization analysis. We have talked about linear regression, and today we'll talk about the linear optimization. We have a linear this and linear that. What is linear relationship anyway? In a linear relationship, the mathematical relationship between the independent factors can be either addition or subtraction. On the other hand, in a nonlinear relationship, the mathematical relationship between the independent factors can be either multiplication or division. Let's see some examples. Suppose we assume that a used car's resale value is dependent on two independent factors, the car's age and the car's mileage. We use x sub 1 to represent the first independent factor, the car's age. We use x sub 2 to represent the second independent factor, the car's mileage. Two different analysts get two different models. We call the first model the linear model. Why? Because the relationship between x1 and x2, the two independent factors, is a subtraction. We call the second model the nonlinear model because the relationship between x1 and x2 is a multiplication. So some classmates may ask a question. What is the advantage of using linear model rather than nonlinear model? As you can see, in the linear model, we can look at each independent factor's influence on the dependent factor. We will talk about the nonlinear analysis later in this semester. In this lecture, we focus on the linear optimization analysis. When we perform the linear optimization analysis, we need to go through three steps. First, we want to establish the optimal objective and find out the factors that can lead to this optimal value. We call the factor that will have the optimal value the objective variable. We call the factors that can lead to this optimal value the decision variables. Second, we want to combine the objective variable and the decision variables in a mathematical equation. We call this equation an objective function. Third, we need to consider all constraints we are facing during the data analysis process. A company could only have a limited number of resources. When we want to reach some optimal values, such as the maximum profit, we cannot produce products endlessly because of our capacities limit, available labors, and available financial resources. We need to consider all these constraints that stop us reaching the optimal values. Now I want to use an example to show everyone how to perform the linear optimization analysis. Let's see an example. The ABC company produces two types of golf bags. The first type is the standard bag. The second type is the deluxe bag. If the company sells a standard bag, the company can get a profit of $10. If the company sells a deluxe bag, the company can get a profit of $9. Assume that the company can sell all bags. How many standard bags and deluxe bags the company should manufacture in order to reach a maximum profit? First, we need to identify the objective variable and the decision variables in this case. We want to reach the maximum profit, so the objective variable should be a maximum profit. We want to calculate the number of standard bags manufactured and the number of deluxe bags manufactured in order to reach the maximum profit. So the decision variables in our case are the number of bags manufactured respectively. If we establish a mathematical equation to represent this relationship, we can get the objective function like the one on this slide. We use uppercase S to denote the number of standard bags manufactured. We use uppercase D to represent the number of deluxe bags manufactured. So the total profit should be $10 times S plus $9 times D. This is the objective function in our analysis. Next, let's take a look at the constraints we are facing in the company. To manufacture a golf bag, the raw materials will go through 4 departments: cutting and dyeing department, sewing department, finishing department, inspection and packaging department. The table below shows everyone the time it takes to manufacture a golf bag. For instance, to manufacture a standard bag, it takes about 0.7 hours in the cutting and dyeing department. It takes about 0.5 hours in the sewing department. It takes about 1 hour in the finishing department. It takes about 0.1 hours in the inspection and packaging department. The data on the right side shows everyone the hours it takes in each department to manufacture a deluxe bag. No matter how many bags we manufacture, there is a limit of total available labor hours in each department. For instance, in the cutting and dyeing department, the number of hours needed for manufacturing the standard bags and deluxe bags must be less than or equal to 630 hours. In the sewing department, the total hours needed for manufacturing bags must be less than or equal to 600 hours, and so on and so forth. Now let's establish the constraint equations to show the relationship in a mathematical way. In the cutting and dyeing department, the total available labor hours is 630. It takes this department 0.7 hours to process one standard bag. It takes the department 1 hour to process a deluxe bag. If we manufacture this many standard bags, this many deluxe bags, the total hours combined must be less than or equal to 630 in the cutting and dyeing department. In the sewing department, the total available labor hours is 600. It takes the department 0.5 hours to process one standard bag, about 0.8 hours to process one deluxe bag. If we want to manufacture this many standard bags and this many deluxe bags, the total hours combined must be less than or equal to 600. We can use the same strategy to establish the constraint equations for the finishing department and the inspection and packaging department. Here we need to pay attention to some implicit constraints. The implicit constraints refer to the constraints that are not mentioned in the analysis requirement. However, the decision variables should have certain requirements from a practical standpoint. In our case, we have 2 implicit constraints. the number of standard bags manufactured cannot be a negative number. Neither should be the number of deluxe bags manufactured. These two constraints are not mentioned in the analysis requirement. However, we should consider from a practical standpoint. In the future, if we find that the value for S or D is negative, then we should know that the analysis result is not accurate. Now I want to show everyone how to perform the linear optimization analysis in Excel. In this data table, we record all information that are related to our analysis. When we perform the linear optimization analysis in Excel, we need a new add-in called Solver. Click on the Data tab on the top, and on the very right end, check if you have a button called Solver. If not, click on the File tab on the top, and then click Options. Click the Add-ins on the left. Excel Add-ins is listed in the drop-down list, and then click the Go button. Next, check the box before Solver Add-in, and then click OK. Now you should find the Solver button under the Data tab. We'll use this Solver Add-in to perform the linear optimization analysis in Excel. Before using Solver, let's implement the objective function and the constraint functions in the dataset. Our objective function is to maximize the total profits. To calculate the total profit, we use the profit from each standard bag to multiply the number of standard bags manufactured. And then we use the profits from each deluxe bag to multiply the number of deluxe bags manufactured. Let's go back to the dataset. In cell B16, I want to type in equal sign, and then click on cell B14, the number of standard bags that will be manufactured. To multiply the profit from each standard bag, the value is in cell B9, so click on cell B9, plus the number of deluxe bags that will be manufactured. To multiply the profit from each deluxe bag, which is in cell C9, click on cell C9. So in cell B16, you should have equal sign B14 multiply B9 plus C14 multiply C9, and then press Enter button on the keyboard. Currently, we haven't get the number of standard bags and the deluxe bags manufactured, so the total profit should be 0 in cell B16. Next, we want to implement the constraint equations. In the cutting and dyeing department, the hours needed for the manufacturing process should be less than or equal to 630. Let's calculate the total hours needed for manufacturing the standard bags and deluxe bags. In cell B19, type in equal sign, and then click on cell B5. This is the time that is needed for manufacturing one standard bag. And then type in asterisk. Click on cell B14. This is the number of standard bags we plan to manufacture. Plus, click on cell C5. This is the time that is needed for manufacturing one deluxe bag. And then asterisk. Click on cell C14. This is the number of deluxe bags we plan to manufacture. Now you should get the total hours needed for manufacturing the standard bags and the deluxe bags in the cutting and dyeing department. Press Enter on the keyboard. You should get 0 because we haven't calculated the number of bags yet. Now let's use the same strategy to establish the constraint equation for the sewing department. In cell B20, type in equal sign and then click on cell B6, multiply cell B14 plus cell C6, multiply cell C14 and then press enter. In the finishing department, type in equal sign and then click on cell B7, multiply cell B14 plus cell C7, multiply cell C14 and then press enter. We can do the same in cell B22. Type in equal sign in B22 and then click on cell B8, multiply B14 plus C8, multiply C14 and then press enter. We have finished the objective function and the constraint functions. Now we are ready to use the solver to perform the linear optimization analysis. Click on the Data tab on the top and then find the Solver button on the right. Click on Solver. First, we want to set up the objective. In our analysis, we want to maximize the total profit, and the cell B16 holds the value of total profit. So let's choose cell B16. Click on the button next to Set Objective, and then click on cell B16. Click the button to confirm. Our goal is to maximize the value in B16, so choose Max as the option. Next, we want to identify the decision variables. In our case, the decision variables are the number of standard bags manufactured, the number of deluxe bags manufactured. These two values are in cell B14 and C14. So click on the button next to by changing variable cells, and then select cell B14 and C14. Click the button to confirm. In the box below, we need to set up the constraints. Our constraint is the actual hours needed for manufacturing standard bags and deluxe bags in each department should be less than or equal to each department's capacity. Let's add this constraint into the box. Click on the Add button next to the box. In the box on the left, we want to choose the actual hours needed for manufacturing the bags. They are in cell B19 to B22. So select this range from B19 to B22. These are the actually needed hours for manufacturing the standard bags and deluxe bags. And then click the button to confirm. In the box in the middle, choose less than or equal to. In the box on the right, click on the button and then choose the capacity limit. They are in cell C19 to C22. So select this range and then click the button to confirm. And then click OK. We set up the constraints in our analysis. Next, you want to check the box before make unconstrained variables non-negative to show the implicit constraints. The number of standard bags and the number of deluxe bags should be greater than or equal to 0. In the drop-down list below, make sure you choose Simplex LP. LP in this case represents linear optimization. We want to perform a linear optimization, so we choose Simplex LP. In the future lectures, we'll also talk about nonlinear. For those cases, we should choose nonlinear. But in this case, we should choose Simplex LP. And then click Solve button. If the solver can find a solution for us, then on this window, we should find Solver find a solution. Otherwise, the window will show us that solver couldn't find a solution. Choose Keep Solver Solution and then click OK. In the dataset, we found that solver did find some solutions to our questions. First, according to our manufacturing capacities, the maximum profit that we can reach at this moment is $7,668. In order to reach this maximum profit, we should manufacture 540 standard bags and 252 deluxe bags. Now let's check the constraints. To produce this many standard bags and deluxe bags, the X-ray hours needed in the cutting and dyeing department is 630. It's equal to the maximum capacity, right? And then in the sewing department, the X-ray hours needed is 480. It is less than the maximum capacity. In the finishing department, the X-ray hours needed is 708. It is equal to the maximum capacity. In the inspection and the packaging department, the X-ray hours needed is 117 hours. It is less than the maximum capacity in this department. From this result, we can find that all constraints are satisfied during the manufacturing process. This is how we perform the linear optimization analysis in Excel. But some classmates may have a question. What are the managerial implications of this technique? There are two advantages of using linear optimization analysis. First, this technique can consider two or more decision variables, so it can help us to fully use the available resources in the company. Second, these techniques also considered the constraints or limitations we could face in practice. In other data analysis techniques, such as the linear regression model, when we investigate the relationship between the independent factors and the dependent factor, we only collect data for those two factors. We really didn't consider the capacity limitations, constraints we could have in practice. So the result we received from the linear regression model could be ideal. However, in the linear optimization analysis, besides the optimal value, we also considered the constraints we could have in our company. So the result from the optimization analysis is more realistic than the one from other models. These are the advantages of using the linear optimization analysis. In eCollege, I also uploaded a developer guide to show everyone how to perform the advanced linear optimization analysis. After this lecture, please take a look at the developer guide on eCollege. This concludes this lecture. I'll see you soon in the next one.